Hello, hi everyone. This is Ramandeep and I'm back with yet another video that is all paths from source to target. This is a Leetcode problem. And in this problem, basically we are given a directed acyclic graph, that is a DAG, which has n nodes and they are labeled from 0 to n minus 1. And what we have to do in this problem is find all possible paths from node 0 to node n minus 1 and return them in any order, right? So starting from node number 0 ending at node number n minus 1, there are multiple ways. There can be multiple ways. So we have to store all of those paths in an array and we have to return that array. Okay, so we are given the graph. The graph is, let's better understand the problem statement using an example. Okay, so let's take this example. We have this example 0 1 2 3. So we can see that in this DAG 0 1, then we have 2, then we have 3, and then we have an edge from 1 to 3. So here you can see that we have to start from this node, that is node number 0. We have to end at node number 3. We have 4 nodes numbered from 0 to 3, right? So what are the possible paths? You can see that one of the path is this 0 1 3, another path is this 0 2 3. So we have total 2 paths here through which we can move from node number 0 to node number 3. So the answer here is 2, right? So how are we going to solve this problem? What we have to do is, what we can do is, like, to solve this problem, it's basically easy. We have to use DFS. We can use DFS. Start the DFS from node number 0 and take node number 3 as the target node, right? And like this, we have called the DFS function for node number 0 and node number 3. This will recursively call itself for node number 1, and then we'll have same target node. And also we keep a array. We also keep a array along with that DFS function. That array stores the current DFS path, the current nodes for which we are calling the function. So currently we are having a vector, we are having an array associated with these function calls. For the very first function calls, I have stored 0 in that array. So let's also keep an array here along with these two arguments. So keep an array. Initially the array had 0. Now this array has 0 1. Okay, then we call this DFS function. We can see that for node number 3, and this array also has node number 3 there, right? Now we can see that the source and the target are same. They are the same. So in that case, we'll be pushing this array into our answer array. So we have an answer array which is a 2D array. In that answer array, we push this array containing 0 1 and 3. Fine, and that's all. We move back to node number 1. We can see we move back to node number 1. Now from node number 1, here I had only one way to move to node number 3. There is no other way. There is no other node to visit from node number 1. Remember, this is a DAG. We do not have to use a visited array because it's a DAG. So why? Because while I'm moving from 0 to 1, I know that I will not be visiting 0 because 0 is not included as a child of node number 1. Fine. So that's why there is no chance to revisit the node from which we are coming. So that's why we do not need this visited array. So now I'm here at DFS 1 3, and what I have to do is हाँ ऋतिक बोलो, आ जाओ ठीक है। Okay, so here we have to, from node number 1 we can't call DFS function recursively for any other node except for 3. Again move back to node number 0. So from node number 0 I can now call, so these calls are out of this call stack, so this is a call stack. Now from this DFS I will call this function DFS for node number 2, and then I'll pass node number 3, and in this array I'll have 0 and 2. Now from the array that I have here, from this point I will call the DFS function for node number 3, and the array will contain 0, 2, 3. So now we'll have 3, 3, and then we have this array. Fine. So again, the source and the target vertices are same, and now I'm going to push this new array into this array. So we'll have 0, we'll have 2, we'll have 3. Okay, so this is my answer. This 2D array containing two arrays. The first one is 0, 1, 3. The second one is 0, 2, 3. Right? And that's all. These are the paths which we have here for this graph. Starting from node number 0, ending at node number 3. Right? So that's nothing but plain DFS. And let's just jump to the code implementation part. So here we have our all path source target function. Let's calculate the target node. The target node will be the size of the graph dot size minus 1, right? Because here we can see that the size is basically 4, and the target node is 3. And what is the source node? Source node is 0, right? We also declare an array which is path array, which will store the temporary path, the current path. Then we'll also take another array which is a 2D array, which will store the set of paths. So let's call this function, let's call this DFS function, while passing this source node, pass in the target node, pass in the path, pass in the answer. Okay, so here we'll create this function DFS. We'll have a source node, we'll have a target node, then we'll have this path, then we'll have this answer, okay. So if this source is same as the target, then let's push this current source, and then we can also push this path into the answer array, and then here I will iterate over the adjacent neighbors. I will iterate over the adjacent neighbor. Okay, I also need to pass the graph as well. So pass the graph, take the graph here, vector, graph, and iterate over the adjacent nodes of this source. Okay, so for these adjacent nodes, call this DFS function. Call this DFS function for this neighbor, and okay, pass the graph, pass the neighbor, pass the target, pass the path, and pass the answer as well. Right? So I think that's what we have to do, and finally at this end we'll return this answer from here. So let's run it. Okay, it's giving me wrong answer. Okay, I have to just push this node anyway into into the path array, because I'm building the path, right? I'm Even if this source is not equal to the target, I have to push this into the path so that I can remember the path through which I have come. Still wrong answer. That's all what I'm doing. It's hmm. ना, कहाँ यार, इतना थक चुका हूँ ना। मर्जी है। कोई दिक्कत, जहाँ मर्जी लगा ले। Okay, so we need to pass this answer array by address, while this is okay. So that's all. Let's submit it. Now that got accepted. So since this is just a plain DFS, the time complexity and the space complexity for this logic, for this code, will be same as it is for DFS, which is big of n plus m, where n is the number of nodes, m are the number of edges. The space complexity is also big of n. This is not the auxiliary space, while it is the stack space. Fine. So I hope आपको समझ आया होगा ये problem, and this was a medium lead code problem, and you can try this problem out. You can also try, you can go down here, you can click here the similar questions. Now you can try these similar questions to this problem. If you have understood how we have solved this problem, the idea why we applied DFS then you can try to solve this problem using, like, you can try using BFS for this problem, right? After you solve this problem successfully, you can try to solve problem using these, like you can also try these problems given here: number of ways to arrive at destination, number of increasing paths in a grid, which are very similar to this problem. So that's how you solve that's how we solve a variety of problems. The more problems you solve, the more solutions you see, the more familiar you become with these algorithms, and no problem after a certain time appears new to you. So that's all for today. If you like the video, then hit the like button and make sure to subscribe to the channel and stay tuned with me. I will be coming up with something new, and we'll see you soon in my next video.